everyone. It's Melissa Peters here with DORN Companies, coming to you pain-free live to help you live pain and injury-free. Thank you for tuning in today for another episode of the Injury Prevention Academy, brought to you by DORN Companies, the country's leading wellness-based pain management and injury prevention company, committed to reducing costs of healthcare, workers' compensation, and lost productivity, resulting in over $100 million in savings over the last 20 years for our clients. Joining us today is Dr. Laura Cavuoto. Laura received her master's and PhD degrees in industrial and systems engineering from Virginia Tech in 2009 and 2012, respectively. She is currently an associate professor in the Department of Industrial and Systems Engineering at the University at Buffalo, where she directs the Ergonomics and Biomechanics Laboratory and the NIOSH-sponsored Occupational Safety and Health Training Program. Her current research interests include quantifying physical exposures and physiological responses in the workplace to identify indicators of fatigue development. Her research work also aims to understand and model the effects of health conditions, particularly obesity and aging, on physical capacity. She is a scientific editor for Applied Ergonomics and an associate editor for Human Factors and Ergonomics in Manufacturing and Service Industries. So thank you, Laura, for joining me today. How are you doing?
I'm doing all right, trying to enjoy the nice weather that we're finally having here in Buffalo. How are you?
Doing well. So, as we heard, you're an associate professor currently at the University at Buffalo. But looking back at, your research interests, can you give us an idea of what it was that got you involved in work related to fatigue and its relationship to occupational safety and health?
Yeah, sure. So my main start in this line of work began in late 2014, early 2015. Initially, when I came out of graduate school and started as a faculty member, I was working on the effects of health conditions, as was mentioned, obesity and aging on physical capacity, and we were looking at strength and endurance and some of the physical factors that come out of that. And what we found in that work was that the largest effects that we were seeing from these personal factors were observed when the individuals are getting to their physical limits. So when they were reaching a fatigued state. And so that really started getting more into the area of fatigue and how it could influence work performance. And if we're pushing these employees to those limits, how it might affect outcomes. And then at about this time, the trend in wearables and fitness tracking and personalized monitoring became a bigger thing. So Fitbits were gaining popularity and other wearable trackers. And so with a colleague, Fidel Magehead from Miami University, we both started to see how in professional athletics, they were incorporating these types of tracking systems to look at fatigue in athletes and how they could optimize performance and training in order to minimize injury risk. And that got us thinking, how could we apply this into the workplace in order to improve performance among workers and minimize the risk of injury that we might see? And so we started down the direction of looking at fatigue monitoring then.
Okay, thank you. That sounds like quite a trajectory, and I know sometimes how academia you open up one question and it opens up a whole can that leads you down. So that's interesting to hear the connections that can be made. So fatigue in general, I have to say, like most people, I use it a lot in my everyday life. Like, oh, I'm feeling fatigued today. But from your professional and expert kind of standpoint, what's a definition of fatigue that relates to occupational health and safety, and the various components involved?
Sure. Yeah. So fatigue is multi-dimensional. So it brings in physiological factors, behavioral factors, subjective factors in response to demands that you experience. And if you don't have enough time or opportunity for recovery from those demands. And we often have to define fatigue based on its consequences because it's one aspect that I like to think about with fatigue is that it's a process. So it's not an end point. From the time you start working or start doing a task, that fatigue starts to develop. And so this process then results in impairments such as reduced capacity or comfort or performance that are affected by the work that you're doing and how it interacts with your personal factors such as sleep and other environmental factors.
Yes, and speaking to the complex nature of fatigue, I know whenever I was doing a little digging around, there's quite variability in how we look at prevalence. I saw some things that were like 97% of people report one symptom of fatigue, and 43% of people report not getting enough sleep. So, in the work that you've done, and whether it might vary by industry, can you tell us more about the prevalence of this issue of fatigue among
Yeah,
workers?
we did a study a few years back of manufacturing workers, and of those survey respondents, about 57% said that they've reported being fatigued at least some point over the past work week. And similar results were shown by another group that looked at construction workers, that in that case, about half reported being tired at least some days, and about 10% being tired every day. And a study from about almost 15 years now, in 2007, reported around 37%. So I think across industries, seeing almost half of the population reporting being fatigued at some point due to their work.
Wow, that is astounding to think just the large amount of people who are impacted by this issue. And so I think that it's important to start understanding what it is that leads to this. So DORN actually, we did a white paper in July 2018, and we found that there's a variety of workload factors of mental, physical, and environmental nature that contribute to workers experiencing fatigue. So, in the work you've done, what are the major factors or root causes that you see that result in fatigue among workers?
Yeah, so those main categories that you mentioned remain in line with the current evidence of the leading causes. And you can think about it in three main categories: so biological or personal factors, work factors, so either in the job itself or the job organization, and then environmental factors that may interact. So in the biological causes, it's about the alignment of the work schedule with the body's circadian rhythm or biological clock. So we're designed to align with the light dark cycle outside, and our hormone release and our alertness are based on being alert when it's light out, and then our body wants us to go to sleep when it's dark. And when we try to work against that, as might happen in an overnight shift scenario, we are influencing or working against that natural design. And so that can affect our ability to remain alert during work and also to sleep restfully when we're not off work, because it's hard then to try to go to sleep when it is light outside. And so in a study of transportation and warehousing workers, it said that almost 70% reported that because of being on the night shift, they were having shorter sleep duration. And so if you're not getting enough sleep each night, then this has been associated with increased risks of work-related injury. And this gets modified by some personal factors such as age, where older workers are less able to adjust to those night shifts. And by older, it's not necessarily that you're over 65, it's even at age 40, you start to have trouble adjusting to being up at night. So this is a prime demographic in our workplace. And then on the work-related side and the work-related factors, there's a big influence of the time on task or the number of hours that you have to spend doing your task. That is going to add physical load, but also influence or interfere with your ability to get enough sleep at night. So it has almost this combined influence. And then we see effects of workload in terms of the physical demand and how much rest breaks you're getting during the work shift and the nature of the work that you're trying to perform. So we may think, oh, well, I'm not doing physical work, I'm just sitting at a desk reading, and that shouldn't be fatiguing, but they've shown that mental demand and mental tasks can still have a physical effect on the body. So you could, if you have a very stressful, mentally demanding day, could still feel very tired at the end of that day. And so those tasks that require attention or vigilance can be most affecting in that regard. And then if you have to do repetitive tasks where they don't allow you to rest and get a break in between, then you don't have that recovery. And so that fatigue is dependent on having enough recovery from the demands. And that repetition occurs both from the physical and the mental side. So our muscles need a chance to relax as in order to get some oxygen back and flowing, but also our brain and our cognitive processes need a chance to relax and recover as well. I'm going to add that on the in terms of the environmental factors. So if you're working in noisy environments, then it's harder to try to focus on the task that you're doing. So those noise conditions can lead to fatigue or exacerbate some of the effects of fatigue. And then if you're working outdoors in the summer and it's very warm, then that can make the tasks more demanding as well. And so your body can become more tired more easily then.
Yes, so I appreciate the distinctions between the various ways, and then also understanding how even what might not look like a demanding job from an outside perspective, or we can sometimes minimize what it is that someone's going through, can all work towards leading to the prevalence of fatigue among workers in our country and beyond. So when we're talking about an issue that is so widespread, and the more we learn, the more we know, but what are the impacts and implications both for the workers and for the employers, knowing that this is an issue that's impacting so many people?
Yeah, so in the short term and at the worker level, we can think about the cognitive effects as well as the physical. So in the cognitive, this is reduced motivation. So if you're feeling tired or drowsy, then you may not be as motivated to do the work. You might have reduced alertness, so you can't respond as quickly or react, and some reductions in mental performance. And as part of that mental performance, you're actually inhibiting, or they've seen less activation in parts of your brain that are really responsible for problem solving, for situation awareness, for being able to creatively react when you need to, or when you're encountering a unique situation. And so they've seen this in some studies of construction workers where they don't remember the work procedures that they were supposed to perform, or they stop or start the wrong machine because either they weren't paying attention, or they weren't able to pay attention, or they didn't um, recognize what the next step should be. And then on the physical side, we often see reports of discomfort, and those can be targeted or localized based on the task that's being performed. So if I'm doing a lot of work in lifting, I might start to feel that discomfort in the low back. So some of that discomfort more localized, but then reductions in strength and power. So the muscles can't perform as well. And we lose some of our fine motor control. So sometimes this manifests if you think about working too hard at the gym one time and you really push yourself to the extreme, you'll actually notice yourself shaking, right, or tremoring. And we can see this in the workplace, maybe not to that level, but we notice that we can't do things as accurately or as precisely as might be needed for a high precision task. And so these localized effects at the individual can then broaden to the work task or the work level, where we see more errors, more accidents, higher reports of stress and distraction. And that can then lead to reduced productivity, lower work quality, and maybe a need to rework parts in a manufacturing setting because some mistakes were made. And then accidents at the extreme level, which could lead to injuries and illnesses that keep workers out of the workplace. So higher absenteeism and higher costs for the employer ultimately.
Yes, I know. I was poking around and found that according to the National Safety Council, that fatigue costs the U.S. economy about $400 billion annually, 1.36 billion just related to that lost productivity that you're talking about, and that about we see over 10% of workplace injuries somehow affected or related to fatigue. So I think that speaks to the importance of employers taking a moment to think, how can we better understand and support our workers with that? So, with that in mind, can you give some information about common ways of monitoring or detecting fatigue in the workplace and what employers can do to start to understand how this impacts their workers?
Yeah, so I think for employers, it starts by taking an overview of the workplace and understanding first that there's a fatigue problem. So, are you seeing accidents or some of those maybe lagging indicators, but indicators, important indicators that show us that there is a problem somewhere in our workplace, and then looking at what type of fatigue it might be, because we did say it's complex and there's a lot of different fatigue types, and thinking about which workers are being affected so that I can better tailor my solutions to the workers. So to go into how you might do that a bit, there's a number of measures that can be implemented. And for an employer, there's likely not one single measure or one magic tool that's going to tell you the answers to all those questions and whether you're having a fatigue problem and how to solve it. So I recommend starting by just watching the work that's being performed and talking to the workers. I think we often get away from that, and the workers have the best sense of what's happening, what they're going through, what they're experiencing, and what tasks they may be having the most problems with. And then the employers should also, at this level, at this first step, integrate any data sources. Many companies keep their performance data separate from their injury data or their absenteeism data separate. And so you want to integrate those data sources to say, am I having a lot of turnover in a specific department? Am I having a number of people call out because they're not capable of doing the work, so they're calling in sick? Do I have a number of injuries in a certain part of my facility? Because then I can start to target. And if I have injuries that are occurring, even if they're not to the level of maybe an OSHA recordable injury, but if I notice that there's near misses or injuries, then I should do a root cause analysis and see how fatigue is impacting. And then from there, you can identify, is it those who are on shift work and those who are on third shift who are maybe experiencing the negative outcomes? Or is it a seasonal effect where the hot weather in the summer is causing problems for those who are out maybe doing road work when they might be in the shop during the winter time? And then we want to dig deeper. So that gives us the broad overview, but then want to say, okay, now what is the specific problem so that I can really address it, right? And so for that detailed information, we have two main approaches that we can think about. One is subjective and just asking about symptoms and using some of the validated questionnaires that are available about fatigue. So there's a few that have been developed that can target sleepiness or some of the multi-symptom factors. And then also with this, someone may not be able to identify their own level of fatigue, or they might not be willing to, but coworkers may be able to identify behavior change. So a study of electrical workers actually showed that, like, when they work on teams, coworkers were good at identifying changes in behavior that were fatigue related. So you can start polling some of that information as well if you have these individuals working together in teams. And then on the objective side, we can look at generally think about three categories or subcategories of assessment approaches. So we can start with fitness for duty measurements. And then there's performance-based assessments and continuous monitoring. So with fitness for duty, we usually are measuring something like reaction time. So I said that one of the consequences of fatigue is that you're slowed in your reaction uh, to the task or to any stimulus that you present. And this is a common issue in driving and transportation. So if you're driving drowsy, then you can't see those brake lights in front of you. So a reaction time test at the start of the shift may be used to say that you're already fatigued and you shouldn't be on the job because you're not going to be able to respond quick enough to an emergency situation that you might be placed in. And these have been used in transportation, I believe in mining as well. They're desirable in that they're not interfering with the task. So I can have a computer or workstation that everyone just does this test when they clock in for the shift and know whether they're okay for that day. But it doesn't give me any updated information as the person's doing the job. So I don't know if they're developing any fatigue during the task. I just know, did they start fatigued, which is important, but it's only part of the picture. So then we can move to some of the other assessment approaches. So in the performance-based ones, we're embedding the data collection and information gathering into the task. So and a lot of these examples come out of transportation because they've been doing this more regularly. But in a lot of trucks that you see on the road, they'll have lane deviation tracking. And they'll be able to monitor, is this driver swerving a lot, trying to overcorrect, as an indication that they're either distracted or fatigued while driving. This is advantageous in that it's tied to the job task and it has a direct safety relationship. So more likely to be acceptable. We can justify maybe to the employee why we need to do that type of monitoring because there has the direct connection to accident risk. However, we don't have the direct tie necessarily to fatigue. So we can make the connection that you're swerving because you're fatigued, but it could also be you were on the cell phone or some other cause. So then you have to do a little bit more investigation, but it gives you that direct measurement of this performance. And then the third type, continuous monitoring. This is an area that our group has been working in for a while. And in this case, you're measuring the physiological or physical response for the worker and how they're reacting to the task. So you can either look at, as I mentioned, physiological indicators such as heart rate or eye pupil dilation or blinking, or you can look at physical factors such as the motion that they're doing or any of the tremor, if you notice that would be present, or even balance might be an indicator. So there are a number of options of personal indicators. And one of the then challenges is which of those indicators is right for my task, right? What is my task influencing and how do I choose which to measure? And so what we've been doing is trying to identify which sensors and which methods are most suitable for physical fatigue monitoring. And what we've shown in our lab studies is that for a manual materials handling task, for example, we could show that walking behavior changed. So individuals actually walked differently as they got tired during this lifting task. So there are a number of options to choose from for detection and monitoring. And so there's some, I guess, factors that need to be considered in which of these should I choose, right? There's so many. How do I go about choosing it? And so you can think about what's going to be most usable in the field. So if I need to be out in um, a remote environment, or am I in a controlled workplace? What can I implement and how? So maybe it's easiest to just ask the worker a question. That's all I can do. If that's all you can do, that's maybe good enough. But then also the responsiveness and to the type of fatigue. And that's why that first step of really isolating what type of fatigue you think your employees are experiencing is important. Because if I just start monitoring eye closure through dash cams, um, then if my workers aren't feeling drowsy, or um, it's not a vigilance cause to their fatigue and their accidents, then my information doesn't match with what I expect. Now, in that case, for drivers, that's likely the type of fatigue, but I need to do that assessment up front. Um, and that's
Okay.
where, oh, go ahead.
No, I'm just, yeah, that's fascinating. So, it's like so many things to consider and really working to find the one that's relevant to work being done. Because even the wearable sensors that I saw that your team had been using, as you really start to understand the way various tasks start to expose fatigue, and getting away from, kind of a one size fits all, like, oh, well, that means they're fatigued, really getting to the nuance is just, I mean, it's, my brain is trying to wrap itself around it all.
Yeah, and that's where it's hard because once you know that there's fatigue problem, you have to, that doesn't solve the problem. And so that's why if you can get more specific on the detection piece, then you can determine what's the best way to mitigate the issue. And that's really I guess our end goal is to eliminate fatigue, or to reduce it as much as possible. So we need that accurate information up front in order to act on it.
Yes, and I didn't mean to cut off if there was any more you wanted to delve into the detection of fatigue, because definitely, I want to jump into a conversation about what this means for choices employers can make to address fatigue once they get, but wanted to give you a chance if you had another point you were working to make towards monitoring and detecting of fatigue.
No, I think the final thing there is just that involving the workers throughout the process is important for making sure that they go along with it. Because you want good data. If you're doing any of these approaches, it's about having good data to make informed decisions. And that's dependent on worker acceptance and worker engagement into the process. So they need to be included throughout.
Yes, it's hard to make decisions that impact people if the people impacted aren't involved, right? So I think we're with you. At the end of the day, it's about what can we do about it. Now you know better, can we do better? And so we at DORN, we've done some work in our injury prevention interventions. We do pre-shift conditioning with workers, manual therapy, some self-care solutions that start to maybe address those symptoms of fatigue like pain and discomfort. And we do see that after being exposed to such interventions, workers report improved sleep patterns, increased productivity, reduced stress levels. So, that being said, in the work you've done, what are some recommendations that you have when there's a safety professional out there who's looking to say, look, I know about it now. Now I want to do about it. What are some options that they have as people really work to address these issues?
Yeah, so I think if we think traditionally in safety, we like to think about the hierarchy of controls. And so our ideal would be to eliminate the hazard. So if I know that there's a certain task or a certain shift schedule that's leading to a problem, then I should try to get rid of it. Um, Now, for some physical tasks that may be feasible, I may be able to redesign the task or change the approach so that it doesn't require either human involvement, or it changes the human involvement so that there's less repetition, there's lower forces, there's fewer awkward postures. So making good ergonomics in those tasks can eliminate some of the hazard. With the ones related, with the factors related to the shift schedule, though, it may be hard to fully eliminate night work in the nature of the current industry. And so providing sleep to those workers in appropriate times may not be a feasible solution. So then we would start to maybe substitute or change how the work is scheduled during those shifts. So reducing how much safety critical work would be done at night, making sure that's all taking place in the day when you have more alert workers. So thinking about the work organization and the work structure so that I'm not overloading those who may be already at risk. Um, and then we can look towards some engineering controls. So this could be either in fatigue proofing, so trying to um, put controls on the equipment or for the task so that if I do have reduced attention, then there's a backup or a safety factor that is not going to lead to a negative outcome. Also, I can make sure that in general workstation design and job design support the worker doing the task so that the effects of fatigue don't negatively impact. Also, on the physical side, as you mentioned, like exercise and other factors and experience are going to affect how demanding the task is. So if I have a healthy workforce, then I can um, minimize, right, or lower the level of demand that's placed on them because they have higher levels of physical capability, higher strength. They don't have other comorbidities. So helping to support employee education, self-management of other health conditions, preventive exercise can play a role in reducing some of the effects of fatigue. Now, this would be at probably our lowest level of the hierarchy in terms of personal protective approaches, but
Mhm.
but it's an important component. So we can't ignore that we want to educate the employees about fatigue risk and about the importance of sleep and sleep hygiene and how other um, chemicals such as caffeine are going to play into their alertness or responsiveness. So we even if we would prefer the engineering and controls, it's about working these controls together. And that's where, as an organization, they often talk about fatigue risk management systems. So having a combined set of policies or practices that the organization integrates into its safety processes in order to manage fatigue as a system level issue. So we can't think about it isolated at a single worker. We have to think about it across the organization.
Understood. So yes, thank you very much for that. So what's in the pipeline now? What comes next in your research? Anything you can give us a sneak peek of anything to come?
Yeah, so we have a few different directions. One thing in terms of the interventions, we did a recent review of the literature and found that there's not a lot of strong evidence in the research literature on what interventions are going to be best. So whether it's a anti-fatigue mat or a certain work support and or task rotation. So we are trying to look into specific interventions for physical fatigue, and also try to encourage documentation of best practices amongst organizations. We've been focusing lately in specific sectors such as warehousing and logistics to also validate more detail about the measurement technologies and the monitoring approaches, and whether we can and how we can put in lightweight solutions that will give actionable information to safety professionals that they can respond to more directly. There's unique challenges in that sector right now, especially with the just increased demand of e-commerce, and so they're pushing workers to high levels of fatigue, has been reported in the news media, and so we're trying to come up with some measurement and solution strategies there. And then in manufacturing, looking at, so in production planning, we often isolate the actual manufacturing tasks or the work that's being done and we design it without thinking about the human and how it's influencing the human. So we're actually trying to work earlier in the pipeline to say, as we are building models of the production process and the production plan, how can we use this information about the operator that we can now get more information from sensors, but how do we use that earlier in the process to even better prevent fatigue from occurring? So rather than a reactive approach, trying to be proactive in this design process and say, if we know that these conditions are going to lead to fatigue, can we predict those conditions and design them out of the processes before they're even there?
Sounds like you all have a lot of exciting stuff going on, and I agree it could not be more timely. And I look forward to staying in touch and having you on again next time that we have some other research you'd like to share with us. So very much thank you, Dr. Cavuoto, for your time and insight into this major issue affecting workers out there.
No, thank you, Melissa. It was great talking with you.
Yes, and thanks to all the listeners and audience out there. Hope you gained something useful, and I hope you tune in for the next episode. Thanks, everyone.